Friends, welcome back to the Next Bite podcast. And in today's episode, I hope you don't mind snakes because it's going to be very snake and robotic heavy. So if that's okay with you, then I have a feeling that this might be your favorite episode of 2025. So with that said, let's just slide right into it. All right, friends, welcome back to the Next Bite podcast. Today, we're taking a quick little flight over to ETH Zurich, our friends in Europe and Switzerland. But before we get into today's episode, we're going to talk about today's sponsor, and that's going to be Mouser Electronics. Now, folks, if you've been rocking with us for the past 4 years and some change at this point, or 4 years strong, you know that we love Mouser. And the reason that we love Mouser is that they're very aligned with us. This mission to bring interesting topics in tech that are relevant and fresh to everyone in an easy to digest manner. And they make these technical resources, sometimes videos, sometimes articles about what's going on, what's the latest. And there's this one that we're going to be linking in the show notes that's all about medical robotics, right? Like what the past couple of years has been like, what the progress is like, what the regulatory bodies think of it, and what the future holds, what are some of the obstacles. And you know, it's crazy. I remember 2015, I graduated high school. It was around then that I saw the Da Vinci robot, the one that like took a grape apart. You know what I'm talking about? Like
they did surgery on a grape.
Yep. And I was like, that is crazy. It was like skinning the grape, stitching it back up with like ultimate precision. And I was just blown away. Keep in mind, I was going to be a mechanical engineer. That was like a beautiful piece of machinery. And then you read this article, they're like, hey, by the way, last year, the FDA gave approval for the Da Vinci 5 that is supposed to have 10,000 times more computing power than the Da Vinci 4, which was the last generation, that, by the way, did 7 million surgeries. So like the Da Vinci and these robots in operating rooms, it's not a thing of like sci-fi. It's our reality now. I remember hearing it was used in emergency surgeries where the surgeon could not be flown out and they didn't have anyone on site, but a surgeon far away could just kind of tap in and do the surgery right then and there. And then they talk about how the FDA and the EU's regulatory body MDR are working together to set standards, how engineers are like reacting to those by adapting it earlier on during the design stage. They talk about basically holistic snapshot of what robotics looks like in the healthcare system within a page. So like if you even are remotely interested in this, I would highly recommend you check it out because there's a lot of juice packed into a tiny amount of space.
And that's what Mouser's good at, and that's why we like working with them. Absolutely.
And perfect segue into the topic that we're talking about today. Robotics, Da Vinci, flexible. As I said, ETH Zurich, and they have this new robotic snake. Wait for it. This name is incredible. Called the Roboa. Right, get it? The boa. Yeah. Okay. Well, that's not the reaction I was hoping for. But regardless, moving on. These folks over at the autonomous laboratory in ETH Zurich, they decided to take on the challenge of a search and rescue robot, which is very novel, right? It's a great initiative. Obviously, direct impact to people's lives. You help people save people's lives. And before they started going down the design path, they met with the Swiss search and rescue team. And they were like, okay, like what kind of things are you guys looking for feature wise? What kind of, obstacles do you deal with? And very early on, they kind of axed out robots that have wheels. They're like, some of these spaces that you need to get to, that's not going to work. Robots with wheels, they don't do great in like uncertain terrains. Shout out Mars rover. You're the only one that's been killing it out there. But what was interesting is that their professor who was like assisting them and giving them guidance was like, there's this really interesting expandable robot thing that not a lot of people have worked on that maybe you should look into. And that ended up being the foundation of this design. Now I'm going to do my best because, this is an audio medium to explain what I mean by expandable robot. Imagine if you have one of those like gloves, the rubber gloves that you put on and they're kind of folded into themselves. You take it, you blow into it and it expands. Imagine that, but for like an entire robot that can expand out 100 meters, right? it functionally works the same way. It's the entire body is made up of soft fabric that is expanding internally outwards to reach wherever you want it to reach using compressed air.
Yeah, exactly. Similar to your analogy, right? It's similar to blowing a glove, or what are those things called that like they're rolled up and then you blow them in parties? And do you know what I'm talking
I know
about?
what you're talking about. Yep. That looks
So
like a
those
frog's
little party
tongue.
kazoo things, right? You blow in them and then they unfurl, right? It's very similar, right? The fabric is rolled up. You provide pneumatic power, air pressure, which causes it to expand, and that's also actually what they use for the control method as well. And this allows them to not only create a tube that expands and can extend into tight spaces, but they can also steer it and monitor it in real time. And essentially by doing this, right, you've got like unrolling a sleeve in your shirt. Essentially, you've got the ability to navigate through really tricky paths, through tight spaces, up to 20 meters long. And they say it's a vine-like robot, but I love that the name Roboa lends some credence to snake, because it is a snake-like robot that instead of having a giant 20-meter long boa constrictor run through your house, you'd be deathly afraid. This giant 20-meter long snake actually is designed specifically for search and rescue, for inspections, for exploration. It's designed for life-saving.
Well, yeah, that's the cool thing, right? The drive for this was search and rescue. So that's how they came up with this robot thing. And like you're saying, the benefit of it being snake-like instead of a rigid body, it articulates in any way that you want using that flexible body and the compressed air. But then as they were accomplishing this task, they realized that all the things they've done fits really well into the inspection world. And that's somewhere that, like, Daniel, you and I have a little bit of experience in, given our senior design was for developing a robot for corrosion inspection, right? And we faced our own challenges creating systems that could navigate through tough terrain to do that. Now, funny enough, this is going to come real full circle. Wevolver, which is how we came together to produce this podcast, one of the ways that I found out about them early on was because I was in college investigating robots that could do something like this. And I came across Carnegie Mellon's articulating robot that was made for inspections and such things. This is like 6-7 years ago.
The super full circle.
super full circle. But it's crazy to see like how far this design has come. And if I'm not mistaken, by the way, these folks are the first that are tackling this like soft body articulating snake, because everything else I was looking up earlier today, just as a bit of research, Johns Hopkins is big on snake robotics, and theirs is a rigid body. Carnegie Mellon is still continuing with their rigid body. NASA JPL has a very interesting design, but also rigid body for exploring Mars. So these folks have taken a very novel approach, and it seems to be really paying off, which is exciting.
Well, and it's not only unique because it's soft, right? It's also unique because it's expandable. Like that, those two that go hand in hand are what define this. But it makes it so unique and so effective. So
absolutely.
Let's talk a little bit more about the design and the advantages that come as a result. Because it's small, because it's soft, it doesn't have the propensity to hurt anyone or anything, including damaging surfaces. So it doesn't matter as much as like if you're crawling through rubble in a search and rescue scenario, but if you're in an inspection situation, the whole advantage, or one of the main advantages for using robots, is to do non-destructive inspection, and it's called NDI, and there's a big market for that. But if most robots actually have a risk of mutilating the pipe or the enclosed space that they're trying to inspect, this robot does not. So you don't need to be worried that this will damage the surface because it's soft. It has actuators inside of it that allow it to turn in any direction in 3D. It's outfitted with a bunch of sensors, cameras, microphones, mapping tools to help it see, hear it's under the surroundings, and then also help the person that's controlling it see where it is and look around. One of the interesting things that I thought was really cool is it also has a liquid supply line in it. And at first I was like, What could you use a liquid supply line for? But in a search and rescue situation, you imagine you find someone who's trapped in an enclosed area underneath rubble, and you find them, and you can't get to them immediately, right? You know it's going to be a day or so before you're able to pull them out of there. This robot could deliver food, water, or medicine through this liquid supply line in a way that is not only intended to locate people in a search and rescue situation, it's also intended to help supply them so that they can survive. And again, it just goes back to the origin of this as a life-saving device. And then it's awesome to also hear the potential additional applications in the inspection realm as well.
Completely agree. And it's, I don't care what anyone says, size matters. And these guys really knocked it out of the park there. If you look at this robot, like I said, it can expand up to 100 meters. That's like for our friends in the United States, a little over 300 feet, right? And the box that they carry it around in is like, I don't know, Daniel, what would you say, like the size of a suitcase?
Yeah.
The size of a suitcase.
Yeah,
so
it could fit in your backpack.
The fact that something, again, life-saving, so, I don't know, useful and flexible in terms of its application, not like the physical nature of it, can fit into such a small package, that's very impressive. And again, the main thing it uses is electricity and compressed air, which is abundant pretty much everywhere, which makes it, I'm betting, very handy for those search and rescue teams. And I'm guessing that's one of the feedbacks that they gave them. But yeah, that's the gist of what they've accomplished here. They killed 2 birds with 1 stone. You got search and rescue, you got inspection. And in terms of next steps, like this is a student team, keep in mind, right? Like this is something they just went to do as a proof of concept. Well, now they're so energized by it that now that the project is done, they want to bring this to market. That's what the future holds for them. I think it's a team of 4, and they're actively working on commercializing it.
Well, and one other interesting thing to mention in terms of applications, right? So the first of that being the search and rescue. It can clearly do things that humans, or go places that humans can't go. It can go places that search dogs can't go. It can go places that flying drones can't go. And most robots also can't go to the same, imagine someone stuck in the rubble, 30 feet through rubble. This thing can fit through tight spaces 5 to 10 centimeters wide and extend, like you said, up to 100 meters to go find someone or something, the thing that you're looking for, the person that you're looking for, in that confined space. Most robots can't do that. Most drones can't do that. Humans definitely can't go down there. So this is an awesome, flexible design for rescuing and finding people. But in terms of inspection, right, one of the big things about inspecting pipes, one of the biggest markets for inspecting pipes is underground natural gas pipelines.
Yep.
And one of the interesting things about that is, like, a lot of robots, because they use electricity, there's a concern of, like, if there's sparks, natural gas in there, and if there's sparks from the electronic control, is there the propensity for this thing to start a fire or an explosion? And I actually worked on something, a robot for natural gas pipeline inspection, and we did a bunch of research to, like, try and prove that there was really, really, really low risk of this or something like that. But it's completely different to say, hey, our control method is air. Air doesn't cause sparks. It's not electricity with brushed motors, and we just hope that the spark doesn't find its way to some natural gas, right? This is very, very safe for usage in gas pipelines or in areas where there's a gas leak without there being concern of it starting a fire or creating an explosion. Obviously, I think that's pretty interesting, but one of the things I wanted to mention is this is back in, I think, 2021 or 2022 when they first published a paper about Roboa. They did a test scenario where they were repeatedly able to locate a trapped person that was at least 10 meters inside a simulated rubble environment, which is insane to see. Like, imagine in my mind, 10 meters away or 10 meters into rubble in a collapsed building, this remote-controlled robot was repeatedly able to locate them. Since then, they've made it stronger, they've made it faster, they've made it longer, they've added additional sensors. I can only imagine what the capabilities are now for search and rescue, knowing that they demonstrated this with really, really high effectivity, 2-3 years ago.
What's curious to me is that the development, again, the original idea was search and rescue, but developing for search and rescue seems to be almost a stress test of developing something for inspection. And I'm wondering if the path to commercialization for them is going to be, make the money from the inspection side of things and then potentially give it away when it comes to the search and rescue for government bodies and things like that.
Yeah, no, I'm with you. And it's not often that like the original problem people are trying to solve is the thing that ends up making them money. But yeah. I think it's really interesting. We should anyone listening should go check out their website. We're obviously going to have this article linked in the show notes, but their website's really interesting as well. It includes a lot of videos about its applications on industrial inspections, its applications in search and rescue. It's Roboa, ROBOA.ch. It's definitely interesting to check out. And the reason I'm pointing you there is because I want you to help them commercialize. So if you've got a use for a search and rescue robot or for an inspection robot, you should check out their website and request a pilot, because everyone knows, if you've been listening to the podcast long enough, my pet peeve is when awesome technology gets developed and then collects dust on a shelf because the team that researches it is not often the one that has the capability or has the tools at their disposal to go commercialize it. This seems like a team that could do both. So I'm really excited about the potential future that lies ahead.
This is true, by the way. It really is his pet peeve. Even when the camera's not rolling, he just keeps going on and on about the tech that just doesn't make it out of the lab.
I text for Bode on Saturday nights. I'm like, man, it just makes me so mad that tech doesn't make it out of the lab. At 2 a.m.
Have you seen this? Have you seen this? The thing that didn't make it out of the lab? But with that said, let's wrap up today's episode. How about that?
Yes, sir.
All right. Folks, what if I told you that all these search and rescue efforts that have been going on for God knows how many years, we've just been doing them wrong? We try to get robots in there. Those robotic dogs. No, that's not what they're built for. Well, I have good news. Some amazing researchers at ETH Zurich have come up with a completely brand new model that is based around a snake. So if you're afraid of snakes, I guess this is a bad news. But if you're, a fan of search and rescue efforts, great news, because this snake expands by air, can expand up to 100 meters, can deliver, water and medicine, and it can interact with people that might be stuck somewhere to help rescuers actually get to them very effectively. They've designed this thing from the ground up themselves. It's designed in a way that does not cause any explosions. There's no risk for that. And it can be applied for things that are not even search and rescue. It can be used for inspection of pipelines. It can be used for corrosion inspection, so on and so forth. The potential for this is so significant that in the coming years, it might just change the way that our authorities go about doing search and rescue. So that's it. That's my whole spiel.